Next 3 days, we're going to do a review of matrices. This does not have an actual section in your book. It's in the appendix, so I'm not going to give you a section. Like I said, today is stuff that I believe you have seen before. The next 2 days, it's called a review, but I don't think you've learned this material before. So over the next 3 days, we're going to do some matrix review, and then the following 2 sections will actually be solving differential equations using matrices. Okay, starting out with the things that I hope you remember. First one, how to find the dimensions of a matrix. And how do I do that? Okay, for example, matrix like this. What are the dimensions? 2 by 3. 2 rows, 3 columns. What does it mean if 2 matrices are equal? Oh, we're starting out rough today. What do you think it means? What have the exact same values? Each element, or each cell, yeah. All of the elements, corresponding elements are the same. I also want us to remember how to perform operations with matrices. How do you add or subtract matrices? First of all, when is it possible? That's multiplying. When what's the same? Same dimensions. To add or subtract matrices, they have to have the same dimensions. I think we can hopefully remember how to take a matrix and multiply it by a constant. Right? Multiply all the elements by the constant. Okay, this one might be a little rougher. Do we remember how to multiply matrices?
Yes. No. That's the only one I remember.
So that's what, like Greta said, the inner numbers have to be the same. You multiply the row by the next column, add all those numbers together, they give you one element. So every row by every column. Do we need to go over that?
Yes.
Okay. Okay, so first matrix is 2 by 2, second one is 2 by 3. Inner numbers are the same, so it is possible to multiply them. What is going to be the dimensions of the answer matrix?
2 by 2.
2 by 3, outside numbers. Okay, every row by every column. So I would do 1 times 3, which is 3. 3 times negative 1, which is negative 3. I would add them and get 0. Row by the next column, 1 times 1 is 1, 3 times 0 is 0, 1 add 0 is 1. 4 add 15 is 19. Do you guys get the point? Mm-hmm. And then we would do the next row. I'm not going to finish that because I think we get the point. Okay. Next thing I want us to know is the multiplicative identity. Anybody know what the idea of a multiplicative identity is? Just in general? Multiply by something and get the same thing. Okay, so the multiplicative identity is the matrix I, such that if I take I and multiply it by matrix A, or I take A and multiply it by I still get A. A in this case has to be an n by n matrix. The identity matrix is always n by n. Do you remember what I looks like? Yeah, 1's along the diagonal, 0's everywhere else. Again, I is also an n by n matrix. Next thing I want to talk about is the zero matrix. This is the additive identity. So if I take a matrix A and I add a matrix of the same dimensions that has a whole bunch of zeros, I'm still going to get A back. You guys understand that this just means a bunch of zeros, right? Then I'm just too lazy to write out all the zeros. Okay, let's see if this next one we remember. The associative law. So if I do A and I multiply by that by the product B times C, that's the same as doing A times B and then multiplying by C. That's of course assuming that the product does exist. So if B times C doesn't exist, then this doesn't apply. Distributive law. If I take A and I multiply by that by the sum B plus C, that's the same as AB add AC. Is that equal to BA plus CA? So is AB the same as BA? Think of these two matrices up here that we multiplied. Would we get the same answer if we flipped the order? If you flip the order, you wouldn't be able to multiply, right? You would have a 2 by 3 and then a 2 by 2. Inside numbers don't match. Okay, so this is not the same. So to remind you, that means multiplication of matrices is not what? Commutative. Okay. Next thing we need to remember is how to find the determinant of a matrix. Did you learn how to find the determinant of a matrix by hand, not using a calculator? Okay, well, we'll go back to it, but we did, we think. Okay, can you find the determinant of every matrix? If I'm asking you, the answer is probably no. What needs to be true to find the determinant of a matrix? Okay, here's an idea. Do you remember what's... Oh, we'll go back. Determinant of a matrix. Oh yeah, this we've done this year. You guys have found the determinant. Okay, I'm thinking inverse. We're going to get there. Stop talking. You two are driving me insane. If you want to talk, go have a tea party in the hallway and then come back when you're ready to talk about matrices. Thank you. Determinant of a matrix. Only for square matrices. So n by n. Okay, so that we've definitely talked about. Last thing before we look at some examples. The transpose of a matrix. Do we remember that? Have we heard that before? Okay, some of you maybe have, some of you have not. Okay, so let's say that we have some matrix A, which is m by n. And our A is something like this, A11, A12, all the way up to A1n. This is A21, all the way up to AM1, all the way up to AMN. Okay. Transpose is labeled like that. the first element is still A11. The second element is A21, all the way up to AM1. This is A12, all the way up to A1N, and all the way to AMN. So this matrix is an N by M matrix. What did I do to the original matrix to get the transpose? This is not helpful. Those of you doing this, I don't know what that means. What did I flip or what did I switch? Okay, you switch the rows and the columns. So what I mean by this row becomes a column. This row becomes a column. So we're going to look at an example with numbers. Let's say A is the matrix plus U 1, negative 1, 3, 2, plus U 4, 0. Our transpose then, this row, first row, becomes a column. Next row becomes a column. Last row, again, becomes a column. We are going to need that. Okay. Any questions so far? I forgot to warn you that today is a lot of definitions. So starting tomorrow, it'll be more applications, but today is a lot of definitions. Okay, I want to return, bless you, not really return, this is new. I want to talk about the multiplicative inverse. Okay, so here's the idea with multiplicative inverse. Let's say that we have some matrix A, and it is a square matrix. It's n by n. If there exists an n by n matrix B such that AB is equal to BA gives us I, the matrix I, then B is the multiplicative inverse of A. The notation for that is this. So that's the multiplicative inverse. This is what I meant to ask you if you've found before. Have you learned how to find the inverse of a matrix without a calculator? Okay, so we're not sure. We have seen the inverse of a matrix though, right?
Yeah.
Okay. Okay, do we know how to tell if the inverse exists? So the matrix has to be n by n, but not every square matrix has an inverse. Right? Do you guys know when it does and when it doesn't? It is something with the determinant, yes. Any idea what it has to do with the determinant? When the determinant equals 0.
Is that right?
What does that mean? Okay.
They're co-planners.
You just went off the deep end on that one. Okay, definition. If A is an n by n matrix and the determinant of A is not 0, we say that A is non-singular. Sorry, I ran out of room. Therefore, if the determinant of A does equal 0, we say that A is singular. Here's why we care about that. If an n by n matrix A has an inverse. Oh, not if. And n by n matrix A has an inverse. If and only if A is non-singular. So if there's an inverse, it means that the matrix is non-singular, and then the other way also. If the matrix is non-singular, that means there has to be an inverse. Okay, so this is leading us into how to actually find the inverse. We will be doing it without a calculator. Okay. Let A be n by n and non-singular. Let the term Cij be equal to -1 to the I plus j times big M of ij, where big M of ij is the determinant of the n minus 1 by n minus 1 matrix obtained by deleting the ith row and jth column from A. Then the inverse, you take 1 and divide by the determinant of A. This C of ij is a constant, so you find all of those constants, and then you take the transpose of that matrix. Okay. So I think we look at this and we're like, I have no idea what that means. Right? So I think it's best to just look at an example. It looks really complicated. It's actually not too bad. So we're going to do a few different examples with this. Okay, so let's say A is 2 by 2. We're first going to look at just the general case, and then we'll do some with numbers. So this is A11, A12, A21, A22. If we want to find the inverse, it's going to be 1 over the determinant of A. Are we okay finding the determinant of A? Okay. So then here's what happens. For this first spot, I'm going to ignore that row and that column and find the determinant of the matrix that's left. In this case, we don't have a determinant, we just have an element. So that will go here. So for this one, same thing, ignore that row, that column, look at what's left. So that's A of 2, 1. This one, ignore the row and the column, we get A of 1, 2. This one, ignore the row and the column, we get A of 1, 1. We take the transpose, but before we do that, there's one other thing we need to do. I didn't do this yet, the -1 to the I plus j. This is 1, 1, so I is 1, j is 1. If I add 1 plus 1, I get 2. -1 squared is positive. If I go to the next one, 1 plus 2 is 3. -1 to the 3 is negative, so this is a negative. This one, 2 plus 1 is 3. Again, the negative. 2 plus 2 is 4, giving us a positive. So then we get 1 over the determinant of A. Take the transpose of this. So we get A22, negative A21, negative A12, and A11. Does that make a little more sense than everything we wrote at the top? Okay. Example 3. Our matrix is 2, 5, 1, 4. We are going to find the inverse of this matrix. Start by finding the determinant. How do I find the determinant of a 2 by 2 matrix? Okay, so this way multiplied, we get 8. Subtract the other way. So we get a determinant of 3. So one thing to check, determinant is not 0, which tells us this matrix is non-singular and an inverse does exist. So our inverse then is going to be 1 over the determinant. Okay, what I normally do here is I figure out the signs first. So 1 plus 1 is 2, so this will be a positive. This will be a negative. Here, second row, first column, that'll be 3. Negative 1 to the third is negative. So I like to do that at the very beginning. So here then, ignore the row and column, we get 4. Here, ignore the row and column, we get 1. Here, row, column, we get 5. And then row, column, we get 2. One thing that's common, please do not forget that you still have to take the transpose of that matrix. So when we do that, we get 4, negative 1, negative 5, 2. So that is our inverse. Okay. Questions about finding the inverse before I have you do one? Max?
How did you get the negative positive?
So we're doing negative 1 to the power I plus j, I and j being the row and column it's in. You want me to keep going? So like this one, first row, second column, 1 plus 2 will give us 3, negative 1 to the third, it's negative.
Do we need to multiply out the determinant to the rest of the matrix, or do we just like...
No, I was going to say that. I would strongly prefer you don't. I would prefer you leave it like that. I believe WebAssign will take that, but you'll have to see. Okay. Anything else before you guys do one on your own? Okay. Here's our next example. This time we're going to look at a 3 by 3 matrix. So we're going to do 3, 2, 1, 4, 1, 0, negative 2, 5, negative 1. Okay. Are you all comfortable finding the determinant of that matrix? Okay. Do you think you can try to find the inverse? Yeah? Yeah, you're going to find the inverse. Go for it. Take like 4 or 5 minutes. I would prefer that you work with the person next to you so you can catch a mistake early. You know I'm recording this right now.
You just get rid of the first.
I'm like 100%.
Don't you need to rid of all the ones? Yeah.
So take this. I got 25. Okay, Emily, you're right. Did I copy that? Did you?
Oh, you multiply.
Yeah. My 18 is canceled out.
You multiply.
How'd you get 18?
Wait, I have to.
Times
Times
27.
negative 1 minus 5.
Plus 3 times negative 1 minus 5. Oh, I messed up so badly.
No.
Already. First step.
2 times negative 4 minus 9. Oh, damn it. Oh.
So then it's always going to enter.
So once we get the 2, we go.
I don't even know what I'm doing. That's
So now what do we got? We must have somewhere else also. Wait, can I see it? I'm sure we did. Plus 8. We messed up. It's plus 4. Why is it plus 4? I don't know.
So then now we have.
Wait, I don't know why it's plus 4.
Now we have to do it. Okay, so it's to copy. This is where you do the mini determinants.
What you do for the first one, that row, that column.
You just color whichever one you like.
When we did a 2 by 2, we just got to determine it's just the element. Here,
So
negative
whichever
1
is
is
so like one by
your top element.
you cover because that's what you have.
So if we're doing 1, are we still enough to determine?
No, that's just like
dumbbells. Yeah, no, I'm
Yeah.
So then they can be simply as that. Right, so 27? Yeah.
to get that first
Ooh, that was rough. Alright, step 1 complete.
and then like if you try to
Okay, now what's next? My fingers are just now we have A to remove the room.
okay, so
What's so okay for the I'm just gonna do all the let's do the signs first.
oh I did that. Okay.
So it's first row, first column. So that's positive.
Isn't it always just gonna be like opposite, like
Because it's negative.
Positive, like negative.
Then
mm-hmm.
I got 22. Then
Like that. I think it's like that.
okay, first part of the second row.
Alright, so then
Negative
I got
second row first.
because I covered up this.
Oh, we flip-flop the thing. Wait, how did we do this? Well,
Yes.
wait, I don't understand how we did that.
so I think the first one's
Okay, I'm going to give you another minute and a half, and then we're going to go over.
I think this one
Oh, I see. It's kind of down. Like,
So we're taking this one. So cover
this one will be a 3.
and this row.
This one will be a 1. This one will be a -2. Alright, the middle one should stay the same.
what are you doing?
I'm just going corner by corner.
So it just becomes
Add the row and column.
We're
minus 1.
doing
Oh, yeah.
the thing where you flip them.
I don't know. Looking at the corners of the right? So do your row. So wait, maybe I should just, I'm gonna leave, maybe I should rewrite to transpose.
Okay, so we have to make also separate columns. So just everything in the 3 we take the 3 plus. So like this.
Just do the determinant on the scale.
Oh,
Then it's gonna be negative 2, going down the row. 7, negative 1, 4.
Yeah, it was just the determinant was only one number less.
well, you do the determinant, you cover up, you cover up the negatives and take the determinant and then write.
Oh, I
Ew.
Okay, we're going to start going over this.
Oh, wait.
Brain power.
Oh, I thought that was an 8.
Okay, are we ready? Great. I want to remind you of one thing with the determinant. Please remember, a lot of you used the first row. You can use any row or column. So I saw the 0 there, and I used this column. So it's 1 times the determinant of this matrix. And then you don't have to do the second one. minus 1 times the determinant of that matrix. Okay, but please remember, say I chose this one, it would be negative, positive, negative. Okay, if you want to use the first row always, that's fine. I just don't like to do it that way. Okay, so we get 1 over 27, and then we're going to have some matrix that we have to transpose. I did my signs first. I got positive, negative, positive, negative, positive, negative, positive, negative, positive. You guys agree? Yes. Okay, so then for the first element, ignore this row, this column, find the determinant of the surrounding matrix, and you get negative 1. So ignore this row, this column, so we get negative 4. I got 22. Is this a negative 7? I think so. And then a 1, and then a 19, and then a negative 1, a negative 4, and a negative 5. Sorry, I know that that's really small. It ends up being 1 over 27, and then we have negative 1, positive 7, negative 1. So that's this one. And then I have 4. Is this a negative 1? I think. 4, negative 1, 4. And then 22, negative 19, negative 5. You guys agree? Okay. On your homework, there's no way of me knowing if you did this by hand or not, but know on your test, I will require you to do it by hand should I ask you to find an inverse. And you'll have to show some evidence to me that you actually did it by hand. Sound good?
Yeah.
Okay, questions on inverses before we get to the last thing I want to talk about. Last topic today is calculus of matrices. Okay, calculus of matrices. It's exactly what you think it would be. We're going to do an example because I know that that is very vague. Let's consider matrix x of t, which is 3 by 1. First row is 3 cosine of 5t. Second row is 7t squared minus 1. Last row is e to the 4t. We are going to find x prime of t and the integral from 0 to t of x of s ds. If I'm taking the derivative of the matrix, I just take the derivative of every element. So this will be negative 15 sine of 5t. This will be 14t, and this will be 4e to the 4t. If I ask you to integrate the matrix, you're just going to integrate every element. So if we integrate 3 cosine of 5t, we get 3/5 sine of 5t. And then we get 7/3 t cubed minus t, and then 1/4 e to the 4t.